Hey guys, welcome to section 2 and section 5 of chapter 5 of the geometry program. Section 2 is so easy. I needed to say like 2 things about it, and then we're going to move on to section 5. So it really wasn't worth a video. So for your assignment for section 2, you can just watch these 2 very easy examples and call it good for the day, and then jump back on tomorrow when you do section 5. So in section 2, we just needed to explicitly talk about triangle bisectors and what that means. So what I'm talking about here is if you have a triangle ABC and BD is an angle bisector, we wanted to find X. All right, so if BD is an angle bisector, it means that this angle is congruent to that angle. And therefore, if we wanted to solve for X, all we have to do is set the values of those angles equal to each other. So I could move 3x over and add 4, and x equals 6. Literally, that's it, you guys, for section 2. All right, look at this guy. CX is the angle bisector, and we want to solve for X. So I know that this angle has to be congruent to that angle, meaning all I have to do is set the values equal to each other. If I subtract 3x from both sides, then I get x equals 1. Yeah, I'm not kidding. That's all you have to do for this section. It's my gift to you, so have fun. All right, you guys, let's move on. Section 5, we're talking about triangle inequalities, and we have several theorems and corollaries that we need to talk about. The first is a corollary that says the measure of angle 1 in this picture has got to be bigger than the measure of angle 3 and the measure of angle 2. And hopefully you look at this and you think, duh, because we had a theorem that said the exterior angle, angle 1, is equal to the sum of the remote interior angles. So we had the exterior angle theorem telling us 1 is equal to the measure of angle 2 plus the measure of angle 3. So of course 1 has to be bigger than each of those individual angles. Okay, but we're going to use that. So hang on to that guy. Okay, we have another theorem that says that basically bigger sides are opposite bigger angles. So if the side XZ is bigger than the side XY, then their opposite angles are going to be in similar relation. So if this side is bigger and this side is smaller, then the angle opposite is going to be bigger than the angle opposite here is smaller. So bigger angles go with bigger sides. Okay, smaller angles go with smaller sides. All right, we're going to come back to that. Another theorem, it says, if angle A is bigger than angle B, then BC is bigger than AC. So this is the reverse of what we just said. So if this is bigger and this is smaller, then it means this side is bigger and this side is smaller. Okay? Hopefully you guys are familiar with this idea that if this is angle A goes with its opposite side. Okay, B is going to go with its opposite side. Angle C is going to go with its opposite side. All right, we're going to apply all this, so don't you worry. And then one final theorem here, the triangle inequality theorem, which simply means the sum of any two sides has got to be greater than the third side. So if I have side XY and I add it to side YZ, then their sum has got to be bigger than this third side. All right, and it's going to be true for all of the sides here. So that any two sides have to be bigger than the third. All right, any two sides together have to be bigger than the third side. All right, let's apply these lovely theorems. You're going to be given pictures with side lengths, and you need to label the angles from smallest to largest. So remember, we're looking for opposite sides go with opposite angles. All right. So angle Y is going to go with 4. Angle X is going to go with 6. And angle Z is going to go with 7. And they're going to go in that order. So the smallest side is opposite the smallest angle. My smallest side is 4. Its opposite angle is Y. So Y has to be the smallest. The second smallest side here goes with its opposite angle, which is X. Finally, the largest side is 7, and he's opposite Z. So these would be your angles from smallest to largest. All right, let's look at this guy. Now I'm going to be more formal here. All right, my smallest side is 5. He's opposite the smallest angle. So angle A is going to be your smallest angle. The next is 7. He's opposite angle B. So B's got to be your next biggest angle. Finally, our largest side is 10, and he's opposite angle C. So C has got to be your largest angle. All right, now we're going to go backwards. What if you're given the angle measures and you want to label the sides from shortest to longest? Well, the same thing is going to be true. Look for your smallest angle. Smallest angle goes with the smallest side. Therefore, EF has to be my shortest side. Next to smallest angle would be 70. He's opposite DE. So DE has to be your next longest side. Finally, your largest angle coming in here at E, and he is opposite DF. So DF has to be your longest side. All right, what if there's a chance they don't give you all of the angle measures in order to put the sides in order from shortest to longest? Don't fret, because we know that the angles of the inside of a triangle have to add to 180. And if we have 2, we can easily find the third. So we know that 180 minus 100 minus 35 would give us the missing angle. And in this case, our missing angle is going to be 45 degrees. So if they happen to not give you all of the angle measures, you can easily find them. It's no problem. Okay, your smallest angle comes in here. He's opposite QS. Your next smallest angle comes in here. He's opposite SR. Finally, your largest angle is 100, and he is opposite QR, and that is going to be the order of your sides. All right. Sometimes you're not going to have a diagram, so you're going to have to draw one. So they give you a triangle KLM, list the angles in order from smallest to largest, and then they give you just the side measures. So you're going to have to actually draw the triangle and label them, I don't know, KLM. Put in the corresponding sides. So LM is 13, KM is 16, and KL is 25. And now we have to label the smallest to largest angles. So opposite the smallest side would be angle K. The next smallest side would be angle L. Finally, the largest side would be angle M. So don't be afraid to have to draw the triangle. All right, finally, can a triangle have sides with the given lengths? So our last theorem said to us that the sum of any 2 sides of a triangle has to be greater than the third side. So in order for us to test whether the side lengths are okay for a triangle, we have to add all of the combinations and make sure that they're bigger than the third side. So for example, if I add 4 and 7, I get 11. 11 is bigger than 8. So that one checks out. 4 plus 7 is bigger than 8, so that checks out. All right, what about 7 and 8? 7 and 8 is 15, which is greater than 4. So that one checks out. And then what about your last combination, 4 and 8? 4 and 8 is 12, which is greater than 7. So for this guy, yes. These side lengths can hold for the sides of a triangle because the sum of every two sides is greater than the third. All right, let's try this guy though. 18 and 20 is going to give me 38. But is 38 bigger than 40? No. Now the other ones would have worked, right? 20 and 40 is 60. That's greater than 18. 18 and 40 is definitely bigger than 20. But you only need one combination that doesn't hold for this thing to fall apart. It's kind of like our counter example, if you remember that from chapter 2. We just need one set to not work and the whole thing is busted. Okay? So let's look at this last group of guys. Let's say 8 and 12 is 20. That's definitely bigger than 4. 4 and 12 is 16. That's definitely greater than 8. 4 and 8 is 12. Is 12 greater than 12? No. The theorem does not state that they can be the same. It says they have to be strictly greater than. So even if you get a situation where you get the same number, it doesn't hold. 12 is not greater than 12, it's equal to it. And our theorem is strictly greater than. Okay, that's it. You guys finish up your notes, read through the examples, and begin your assignment.